Hello coders, welcome back to another YouTube video, and in today's video we are actually going to be booting into 32-bit protected mode and calling our kernel. So in yesterday's video, or not yesterday's video, depending on when I upload this, we have done this, which is basically we just load the kernel. And I don't remember if we actually accessed the memory from the kernel. If we did, then we did. If we didn't, then we are going to in this video. So, let's get right into the video. The first thing we're going to want to do after we load the kernel is we are going to want to enable the A20 line. I'm not 100% sure what this does, but it is required if we want to actually boot into our 32-bit protected mode. So the way we enable the A20 line is pretty simple. We're going to use a method called fastA20. And this isn't working on all machines, but it works on most. So we're going to move into AL 0x, no, wait, it's in AL 0x92 or AL2 out 0x92 AL, and I believe that is our A20 line, and we're just gonna comment enable the A20 line. Okay, now what we're gonna do is we are going to load the GDT or global descriptor table. And we haven't created the GDT, so we are actually going to do that right now. So create a new file and call it gdt.asm. I called mine gdt.as, so gdt.asm. Okay. Now what we're going to do is we have to fill our global descriptor table with I'm just wondering why it's not highlighting. That's weird. Okay. We have to fill our GDT with, what's it called? We have to fill it with a null descriptor. So, basically 8 bits. You can do dword 0. I do dd0, dd0. That's just kind of what I know. But you can do dword. And now we have to define the code sector. In the GDT_code descriptor has multiple things. First, we define the limit, so 0xFFFF. Then we have to define the base, which is 0x000. Then we have to define the flags, I believe, which is 0, 1, 0, 0, 1, 1, 0, 1, 0, D. And then we have to define, well, that's the access byte. Now we have to define the flags, which is 1100B. And then we have to put 111 because that is the upper limit. And I believe that is it. I'm just gonna check. Alright, welcome back. My apologies for that. There was 2 things I forgot. DB 0x00, which sets the I think it sets another part of the base, and we have to do that for the same one. So that is our GDT code descriptor. I'm gonna wait a minute so you can pause and copy this down. Okay, now that you've had that copied down, we are going to create our data descriptor. And our GDT data descriptor is going to be the exact same as our code descriptor, except if we go down here to, for some reason all these are weird. No, don't, no. Okay, that, and if I can move that probably, okay. Now, this is just gonna be a 0. So, our 1, 2, 3, 4. Our 4th line in the data descriptor is gonna be 100, 100, and 10. And this is the access byte. and this is our flags, and then the upper part of our limit. And I'm going to put a picture on screen which just shows you how, well, not how, it shows you the GDT descriptor table image. And I can explain that if you guys want, so leave a comment down below and I will gladly explain that. Now we have to create our GDT descriptor, which is what's going to contain all the information about our GDT table. So the way we do that is a label that says GDT descriptor, and we also have to create a label that's GDT end, and you'll see why in a minute. So GDT underscore size, and you don't have to do this part, but, well, you do have to do this part, but, like, you don't have to do, what's it called? You don't have to do the GDT size. I just do because it makes more sense. And in the GDT size, we are going to define a keyword, which is going to be, it's going to be our GDT underscore end minus our GDT underscore null descriptor minus 1, because that's how our GDT table likes it. And now we're going to define a double word, which is just going to be GDT underscore null descriptor. So, now our GDT table is done, we have to define a few constants. So code seg, or, we're going to follow convention, code seg equals, and GDT underscore code descriptor minus GDT underscore null descriptor. And the same thing for our data seg equals GDT underscore data descriptor minus GDT underscore null descriptor. And that looks good. So now we finally have our gdt.asm created. I'm going to pause for a moment so you could copy this down. Okay, now that you have that copied down, we can go into boot.asm and we can load our GDT table with the simple instruction lgdt and then our GDT underscore descriptor, and our GDT table is loaded. Now what we can do is, well, we have to do that up here. We have to do disable interrupts, which is interrupts, there we go. And that's just CLI, and then we load our GDT table. Now what we can do after our GDT table is loaded is to far jump. And the reason we're going to far jump is because we need to flush the CPU to make sure no 16-bit instructions are happening. So the way we far jump is pretty simple. Code underscore seg, and then a colon, and then whatever method you want to call this. I'm going to call it initPM. And now if we go all the way down here, and you want to make sure this is like at the very bottom, because you're going to do bits 32, and you can put this like up here, but you're going to like you're gonna make this bits 32, and then you'd have to put bit 16, and it's less work to just put it all the way at the bottom. So now, if you remember from before, we called ours initPM, and we are gonna now set our segment registers. So move AX data underscore seg, and then we're gonna move DS AX, move SS AX, move ES AX, move GS AX, and move FS AX. And now that our segment registers are set, we can move EBP 0x9000, 90,000, and then move ESP our EBP. Now, what do these do? These sets our segment registers, which is going to tell well, it's not going to tell anything, but it's going to offset it, so it's going to be like this. It's going to offset our EBP by the data seg and all other pointers we might create. We have to infinite loop this, and then I will explain what this does. This basically is the 32-bit version of setting the stack, which we do all the way up here. and we set this to this tiny number, 8,000. Now we're making a big boy number of 90,000. So, now that we are in our 32-bit mode, let's just go ahead and run this, and I'm way too used to Vim. Let's go ahead and run that, and let's see. Okay, so we're just gonna run make, and we get GDT descriptor is undefined. Yeah, because I can't type properly. Descriptor. There we go. And make GDT descriptor. That's also undefined. So let's go in our GDT table. Oh, we never included it. Okay. So go to wherever you want to put your includes and just do include gdt.asm. And that will automatically build it for you. So, now that we've done that, we, in theory, should be able to run this. You know, coding doesn't always go the way you want it to, but in theory, we should be able to run this, and it will work. And yeah, it appears we are now in 32-bit mode. 60. Well, let's find out if we're actually in 32-bit mode by doing a pretty simple thing. Move EBX 0x 9000. No. Move EBX B8000. Move the value at EBX and just an H. But we have to tell this that it's a byte. So that is going to put it into the first place of video memory. So now in theory, if we run that, we should get an H instead of a B. But we don't. I wonder why. Kind of figured this would happen, but we are not actually sure. So, I will be right back once I figure out what the hell I did wrong. Alright, welcome back, coders. I am so sorry for that. I realized we never actually told assembly we are in 32-bit mode. So it's pretty simple. We just move into the first control register. Well, no, we move into EAX, the first control register. So CR0, and then we move, and then we OR EAX with a 1, and then we move back into CR0, our EAX. And that should tell it we are in 32-bit mode. That is Audacity, not my, what's it called? My, I'm blanking on the name, but this thing. And now we make, and we should be able to run that. And this should work. We're getting a weird error. I wonder why we're getting a weird error. JMPF. We have our bits 32. SSEXGSFS. Is it this? This. Strange error. Make and that. Okay. Let's find out if that's it. Nope. Okay. So I will be right back once I figure out what isn't working now. Alright. Welcome back. It turns out, number one, in our gdt.asm, instead of a DQ, it is a DW. So make sure you fix that. And in our boot.asm, I don't know why, but it's not really too jazzed about disabling interrupts before enabling the 820 line. So, that being said, now we can make, and this should run. And yeah, if you look in your top left, you should get an H. And before that was box, obviously. And this is my init PM code, so. Alright, now what we're going to do is we are going to write a pretty simple function in our kernel. It is just going to print, well, now we're going to call it our main function, and we are going to have a ret because it is a main function, and we are going to call, well, no, call 0x9000. Make sure it's not 90,000, or else you'll be calling the stack, which I'm not sure what that would do, but it wouldn't end well. So, now that we've written our main function, we're just going to verify that we're in our main function by moving into the value of 0xb8000. Just a simple C. Just simple C. C's are pretty cool, you know. It's got curves. Operation size not specified. We have to specify the byte, you know. And that should work. And we now have, that sounds like a bad word. Okay. You know, C's aren't very cool. We're gonna make it a T. Okay. And now we have talks. That's cool. And yeah, that is our main function, and now we are gonna write that in C. So I will see you guys in just a minute. Welcome back. That was like a second for you guys, maybe not even a second, probably like a millisecond, but you know, it's maybe like 5 minutes for me. Okay, that doesn't matter. What matters is we are now writing our kernel.c. And our kernel.c is kind of complicated because we're going to have to actually create a linker script. And what a linker script does is it basically tells the ld command how to link the file into something the computer can execute. So, that being said, we are going to now totally abandon our kernel.asm, and we are going to create a kernel.c. And our kernel.c is going to need this very specific header, which is just going to specify that we want to jump to our int main function. Int main and return 0. And we need this header in order to specify that we want to specifically go to this one, or else we'd have to specify main as the first function. It's a little annoying to do that. So, now what we're going to do is we're just going to write this real quick. And I'll put this in the description so that you guys can just copy and paste it. It's not anything important and you don't really have to worry about it, but, you know, it's kind of something I include just to make sure. And yeah. So, what are we going to do now? We are going to include, if I can find the hashtag and can type correctly, we're going to include standard int.h. I was going to include stdef, but I don't really need size t right now, so we're going to include stdint. And we're just going to do uint16. Sorry, that's my alarm. uint16 underscore pointer equals, well, pointer is not really very specific. We're going to call it video memory. And we're going to cast 0xb8000 to a uint underscore t pointer. And what this is going to do is it is basically going to create our video memory pointer. So, what we can do now after that is uint16, and, well, no, we have to do video memory, underscore memory 0, and now, you know what, now that I'm thinking about this, we are going to just cast this as a pointer, because, not a pointer, a char. We're going to cast it as a char, because if we had to cast it as a uint pointer, I'd have to do some hex. That I'd rather write functions to do for me, because I am lazy. So now what we're going to do is we're going to modify our make file, and I'm actually going to do it in my text editor. So what we're going to do is we are just going to make sure that this doesn't really get called by specifying ASM with a backslash. And what we're going to do is kernel.bin relies on kernel.c, and then gcc-c, well no, m32-c-f freestanding, and then kernel.c-o, kernel.o, and now we create our linker, which is actually our kernel.bin is going to have to rely on our linker.ld. Okay, now we can just do linker-m elf underscore i386, and I like putting a space there, -t, linker.ld, and I'm just thinking if there's anything else. I don't believe so, so we're just going to kernel.o-o kernel.elf. And now what we're going to have to do is object copy -o binary kernel.elf kernel.bin. And now we can just remove kernel.o and kernel.elf. And that is our kernel.bin created. So that's pretty good, and we're going to actually use the makefile to verify that our kernel.c is being built correctly. So once you've created that, you can just call make, and oh yeah, it needs not kernel, it needs our linker.ld. Now what we're going to have to do is entry main and sections, and then it's going to be pretty simple. A period equals 0x9000, because in our boot.asm, that is where we loaded the kernel. So now we do .text is just like this, a space .text.start, I believe, .text.start again. And now we do space .text and space, and now we do .data is just going to be that, and then .bss is also going to be that, and now we have to put something into that, air quotes, and that's just going to be .data, and now we just put .bss and and then, well no, but an asterisk common. Okay, now I believe if I did everything correctly, that should compile with 168 bytes, which, simple math, yeah, that's correct. Okay, now that we run that, we should get GOX, and we have now successfully loaded our kernel. And in the next video, we are actually going to be defining headers and segments. Not segments. We are going to be defining functions so that we can handle the terminal more easily, and that we don't have to specify this. And yeah. So that is going to be it for today's video. Like I said, in the next video, we are going to be focusing on include files. And our include files are just going to make sure that our headers are, not our headers, are going to make sure that our terminal is easier to use. So, that being said, I will see you all in the next video. As a reminder, my Discord link is always in the description, and so is my GitHub, where you won't be able to access this, but you will be able to access, and I'll show you guys right now, my OS dev, which LS is basically everything we're covering, except my boot.asm actually has comments. So you can go ahead and download that. It is essentially what we're creating in this, but already done. So yeah. And I believe that is it. So I will see you guys in the next video. Bye!